Awesome. Well, thank you for coming. Again, my name is Daniel Bohannon. I'm a really big coffee, some would say snob, I would say connoisseur. But, and yeah, this talk is Invoke-DOSfuscation, techniques for FIN-style DOS-level command obfuscation. And hopefully by the end of this talk, this syntax I'm using here will make a little bit more sense. A little bit about me. I'm a blue teamer. I work for Mandiant, FireEye. Kind of my story is I started out in IT operations, then security operations, then moved into incident response consulting with Mandiant. Did that for about 2 years, and really fell in love just with the detection research, kind of taking ideas and applying them at scale. And so that's what I do now on the advanced practices team at FireEye Mandiant. Twitter handle, blog. I have an obsession with obfuscation for the purposes of better detecting it. So I'm the author of a few projects here, Invoke-DOSfuscation and Invoke-Cradlecrafter, PowerShell obfuscation frameworks. I co-developed Revoke-Obfuscation with Lee Holmes from Microsoft, which is Revoke-Obfuscation is basically using data science to detect obfuscated PowerShell commands and scripts. And then today, Invoke-DOSfuscation, which is command.exe obfuscation. So a brief disclaimer, none of the stuff I'm saying is pointing directly to any one client or customer of FireEye or Mandiant. Most of what we're talking about is things that we've never seen in the wild before, but yeah, don't draw any conclusions there. So, post-lunch, how do we keep the energy high? What are we going to be talking about? I'm going to start just with kind of a high-level overview of the state of obfuscation today, and then we're going to dive right in and look at 3 case studies from this past year of obfuscation in the wild by some pretty interesting threat groups. And these 3 case studies are really what drove me down this road of research. And then we're going to look at obfuscating legitimate binary names on the command line. And then we're going to look a little bit deeper into what I'm calling character insertion obfuscation. Characters you can insert into any command on the command line to try to break rigid detections. And then we're going to combine all those pieces into more advanced payload, like obfuscation of the entire command. And then we're going to do a demo of Invoke-DOSfuscation. And then we'll talk about detecting DOSfuscation. And so, yeah, state of obfuscation. So from a red team perspective, obfuscation is great because it takes little effort to basically get big gains. And the whole point that I researched this is, again, as a defender, I'm trying to figure out what are all the ways that I can mess up my own detections. And let me figure that out first so I can make my detections more robust. And so there's obfuscation frameworks for so many languages available for free out there. And even though I may be biased, I don't really see this slowing down anytime soon just because it's so effective and we see so many attackers continually being creative in how they obfuscate to get around detections. From the blue team perspective, there's actually been some significant improvements in capabilities and visibility over the past several years. That doesn't mean many people are actually taking advantage of this additional visibility, but you have things like Microsoft's AMSI, the Antimalware scan interface, ETW, which has been around forever, but it's kind of being rediscovered in the security world, for event tracing for Windows for additional visibility without having to write your own kernel drivers and stuff like that. You have signatureless detection approaches, which is what this is here. This is a little GIF of the Revoke-Obfuscation work that Lee and I did. But there's always room for improvement because attackers don't stop being innovative. They see these improvements and they say, okay, well, maybe we'll just choose softer targets that aren't taking advantage of this additional visibility. Maybe we'll just disable that visibility. You look at any kind of off-the-shelf Empire downloader now, and it starts with AMSI, script block logging disablement and all this kind of stuff. And most people run that without knowing what it is, and it doesn't matter in most contexts because very few people even have that enabled in PowerShell on their endpoints anyways. But attackers could also just shift their tradecraft to languages that just don't provide this additional level of visibility. So my response to all this is, again, to try to enumerate a problem space that we start to see that we've already seen attackers taking baby steps in, and then enumerating that as best I can to basically create our own detections, and then sharing that research with the community so that others can also go about detecting it. So this is all about command.exe obfuscation. And from a defender perspective, most of the time, a lot of defenders I talk to, they really focus primarily on command.exe and certain arguments being present. Some other things you can look for are like parent-child process relationships. So command.exe launched by Explorer would probably be less interesting than command.exe being launched by WinWord or Excel or OneNote or something like that. You could also look at command as in terms of the source of action on something. So command creating a certain file or modifying a registry or something like that. But the problem is command is used by everything because it's It's a command. So how do you really tell malicious from non-malicious? So first, let's look at 3 case studies of obfuscation in the wild. Nick Carr, he's actually my manager, and we co-authored this blog post last June, and it highlights 3 different threat groups: FIN8, FIN7, and APT32. And so we're just going to do a high-level overview of those different techniques. So last February, we saw FIN8 using this technique, and this was basically in an obfuscated macro. But what they're doing is they're basically setting this PowerShell command. They're basically using environment variables at a lot of different levels. So this bottom one is their PowerShell command, which they're putting in one environment variable, Microsoft Update Catalog at the top. And then they're putting this PowerShell dash, which is going to say run PowerShell, but take the command as standard input. They set that into the second environment variable, and they do command/c echo mvar1 pipe mvar2. So from a defender's perspective, all you'd see is Windward running, and it would spawn this upper command right here. And because it's using process-level environment variables, then you actually don't see what is being resolved. It's all done in memory. So they're using standard input and environment variable hiding to basically keep a lot of their juicy information off of the command line. So that was really cool. Next case study, APT32, also known as Ocean Lotus. APT32 loves to use a lot of open source tradecraft. Basically, as soon as Casey Smith tweets something, then within a few hours, APT32 is right on it. And so in this case, they're using the Squibbly-Doo, the regsurf32 scrobj-dll downloader. And initially, they were using carets, which is commands, escape characters, to break up HTTP, to try to break defenders' signatures that were looking for /i:/HTTP, etc. But then they also switched up and started using double quotes. And we'll talk more about double quotes shortly, but double quotes, and I've talked about this a couple times, or just tweeted out random thoughts of like, why aren't more people using double quotes? Because it's a far more effective obfuscation character than the caret. It applies to any binary spawned by command. But it's really just not used that much. It's, again, kind of surprising because it's so much more effective. Most defenders are looking for carets, but not double quotes. The last one. This single example blew my mind and started this entire research for me 9 or 10 months ago. So FIN7 and APT32 compete for first place in my heart of the most tasteful and creative obfuscation. Like, it's really cool, the stuff that they're doing. They're really small tweaks. So in this case, this is actually the contents of a link file. And what FIN7 did was, in the middle here, they're echoing out this obfuscated JavaScript into this text file. In the JavaScript here, they're doing concatenation. Instead of eval, they're doing concatenation of these substrings and then doing a from char code on the ASCII value 101 for the E. So pretty cool stuff there. But what I want you to notice here is these 2 red boxes. And when I saw this, it didn't make any sense. For me, I was really confused, primarily because of these 2 @ signs in the wscript and JScript. So let's look at it up here. The essence of the command is we have command C. We're setting this wscript command into process-level environment variable X. What they then do is, after they write out the JavaScript, at the end they basically echo the contents of X into command. This is basically spawning another command process where it's taking the input, or it's taking the command as standard input. But then what they do is they put this garbage delimiter. They use the @ sign, and they put it in wscript and JScript. Now, this didn't make any sense to me because I'd never seen the @ sign work that way, and when you try to do wscript, JScript with that @ sign, it fails. But if you'll notice at the end, when they call that X variable, they actually create space after it and then put this syntax in. Now, what this syntax does is it's actually native to command.exe, and it's a string replacement syntax. So it says, okay, you put a colon, and then the string, in this case it's a single character, replace every instance of that string with whatever's on the right side of the equal sign. In this case, there's nothing on the right side. So they're basically saying, take this variable and remove every @ in memory before we pass it to command. Now, when I saw this, I was like, oh my gosh, that is so tasteful. Like, how cool is that? And I had no idea that command.exe was capable of that. And they just used one little sliver of this. So needless to say, we basically, my boss found FIN7 playing around with this payload on a Wednesday. We wrote this blog post on a Thursday, published it on a Friday. I spent all weekend messing around with this concept and wrote this POC called out-fin-coded command, fin-coded as FIN7's encoded, to kind of explore this concept a little bit. And I released it on a Sunday. And as soon as I pushed it out, I just kind of sat back and thought, I wonder if there's more here. It was really cool that FIN7 did this, but I had no idea command.exe supported this capability. What else does command.exe support that maybe we've just never seen, but we should probably start looking for because perhaps FIN7 knows about it. Perhaps other groups know about it. And that's what really started this entire kind of research topic for me. So implications of this research. For defenders, I would say this affects both dynamic and static detections. It affects static more, but initially my thoughts were, well, would defenders even find this interesting if this obfuscation is removed dynamically? Because as defenders, they pretty much care, what do I see in real time, or what do I see in 4688 or sysmon EID1? What do I see from my data sources? Are these characters still present? And in some cases they're not, but in some cases they are. And so just if the initial examples don't seem to bother you as a defender, then we'll get to some that maybe will kind of change that paradigm a little bit. So what we're going to do is we're going to be able, by the end of this talk, to take any arbitrary input command, something even just like a simple echo statement, and add layer upon layer upon layer of obfuscation to get something like that. So hang on tight. We're going to move really fast. All this information is in the 36-page white paper that I put out 2 weeks ago at Black Hat with this initial research. It has all this information and a lot more. But what we're going to do is we're going to take all of these pieces and we're going to stack them on top of each other to be able to basically apply just this wall of obfuscation on any input argument or command and run it out of command.exe. So let's go. First, we're going to take baby steps. Obfuscating binary names. So again, as a defender, I see a lot of signatures and detections and rules that are written for things like, okay, let's say that we see command.exe as a process running, and we see these arguments. If those things are true, then say, hey, this looks suspicious or something like that. Well, aside from the fact that attackers like to just rename binaries, so if they just first copy command.exe to benign.exe and then run all their stuff, are you going to see benign.exe/c blah, 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 right? That's one issue. Another issue is there's a lot of command.exe kind of substitutes, I guess you could say. So if you're looking for like parent-child process relationships, a windward spawning command or something like that, well, are you also looking for windward spawning for files or PCA Lua? There's a lot of other binaries that are kind of in between intermediate programs that will break that initial parent-child process chain. And there's a really good list here by a friend of mine, Advar Mo, that binaries that do other things, and so it has a lot of these there. But a lot of defenders aren't really looking at that. And some of them are only available on later operating systems, so attackers are a little less likely to pick that up because they want their stuff to work across the board. But still, there's a lot of additional binaries to look for. However, I'm not talking about either of those things. What I'm talking about is ways to obfuscate the legitimate binary name on the command line, but to obfuscate it. So one way we can do this is we can use known environment variables and take concatenation of their substrings. So what do I mean? Well, if we just echo program data, on my system, the C drive is C program data. So what if we take the very first character and then the 9th and 10th character and piece that together? Well, we can use this substring syntax for environment variables and do just that. So here's an example of CMD, and this is an example of PowerShell, where some of the characters we just have in plain text and aren't using substrings. This is far more effective like in batch files, because if you actually copy and paste this on the command line, then you actually won't see any of the substring syntax. It'll all resolve right there on the command line. But it's still something. However, I was wanting to figure out, could I find a way to do this where it doesn't resolve on the command line? And so the answer is yes, and the way that I get around that is trying to find internal commands that don't spawn an additional binary. So a lot of commands that attackers use actually spawn additional binaries, like find string, who am I, ipconfig, stuff like that. But set, assoc, and ftype are the three ones that I found to be real useful. So set will show you all the environment variables and their values. Assoc and ftype are related. Assoc is going to show the association of a file extension to the association type. So in this case, we can see ACCDC is access file .16, etc. Ftype is going to basically map that association type with the binary that's going to run it. But why does this even matter? How did I even stumble upon these? Basically, I was looking for any internal command that produced a standard output, anything that contained a string I was interested in. In this case, I'm interested in the string CMD or PowerShell. That's it. So let's take set as an example. If I run set and just do find string PowerShell, I'll see I get two results back. One is the path variable, the other is PS module path. Well, the path variable is probably going to be different on a lot of different systems, so an attacker may instead choose something like PS module path. So in this case, we can just do find string PSM, and that's the only thing that comes back is our PS module path. Awesome. And in the source code of Invoke-DOSfuscation, anywhere where I could, there's just these massive arrays of all these different substrings that will randomly get selected every time so that defenders aren't writing bad signatures just off of find string PSM or something like that. So now that we have this value, what we want to do is basically extract the string PowerShell. And in this case, there's two instances. And what we want to do is find delimiter characters that are case sensitive to basically be able to lift PowerShell out of this command, or out of this output. So the lowercase s and the backslash are the characters that are on either side of those PowerShell strings. So if we make those our delimiters, then it actually chops up. There's a lot of instances of s and backslash. So it chops up this into 13 pieces, where the 4th and the 11th piece are the ones that we're interested in. Now, how do we actually run this on the command line and lift these out? Well, we use the for loop, because the internal for loop in command supports delimiters. So what we basically do is at the end, we run our command, set find string PSM. We define these delimiters. In this case, we ask for the 4th token. So when we run that, it produces and lifts that string PowerShell out. And in this case, we're actually just saying run whatever comes out, which is PowerShell. So it runs PowerShell and interactively, so this is not going to show up on the command line, and then actually enters into PowerShell. So that's obfuscating binary names, and that'll come into play in a little bit. Next, let's look at character insertion obfuscation. So the caret character, again, is probably one of the most commonly used obfuscation characters for command.exe. It's the escape character for command.exe. And if you escape something that has no escapable meaning, then it just is kind of a caret and nothing else, which is great for attackers because they can basically put carets in places to get around rigid detections that defenders might have. I mentioned APT 32's use of double quotes. Again, it's far more flexible than the caret character. Encapsulating parentheses, this was one that I actually came across investigating some newscaster activity. And I don't really think they were using it for obfuscation purposes, but I'd never seen it used before. But basically, you can take commands and subcommands and wrap it with as many layers of evenly balanced parentheses as well. Now, this could be important if you have some rigid detection that's looking for things like multiple commands chained together with ampersands or pipe or something like that. And if you're only looking for white space between those, then parentheses are now going to break that detection. In isolation, a lot of these things don't really seem to be that effective. If we start to merge all these things together, it really makes us as defenders have to try really hard to take into account all these possibilities. Leading and trailing special characters. This is one, I've never seen these used in the wild, but basically there's commas and semicolons that can be used in anywhere where white space is used as a delimiter character in command.exe. So I came across this just writing a fuzzing script to basically pipe in all these different random characters and then see, is this still a valid command? And these are the two characters that bubbled up. And so, yeah, if you think like command space /c space calc, you can actually replace all those spaces with as many commas and semicolons as you want. So that could be really fun if we start to add those up. Standard input argument hiding, we mentioned that in the FIN8 example. A few other ones. This is actually from an older blog, not from myself, but from several years ago. Basically, for batch file obfuscation, you can basically intersperse non-existent environment variables, and they'll just simply be removed when the command runs. This does not work on the command line, but from a batch file perspective, it's a nice way to get some good static evasion. Static detection evasion. You can use custom environment variables where you basically set environment variable values and call that value in the same session, or use existing environment variables like I mentioned earlier. So when I released this outfin coded command POC, part of that POC included a couple of these environment variable substring syntaxes for command or PowerShell. And it's funny because I tweeted this out, and then like an hour later, this guy replies back with this entire command encoded in this way. And so in the tool, basically the way I built it, you can have any input command, and it will basically create these random substring concatenations of environment variables and produce payloads like this. So after digging into this technique, for me, I was really curious, has this already been used before? Do we see attackers using this that maybe we've missed before? And so doing some interesting retro hunts in VirusTotal, this technique's been used for quite a while. This is This is samples from 2012 of the Devourer malware, but there's no doubt this technique has gone back a lot longer than that, of just using concatenated substrings from environment variables. Another one here, this is produced from a really cool tool. It's like one of the smallest obfuscators I've ever found. Like, source code is really small, but like it's a really cool concept. And that's basically, instead of using known environment variables, just start a batch file with the full alphabet into a custom environment variable, and then the rest of your payload is then substrings of that custom environment variable. So this is an open source tool. It's been out for, I think, 2 years now, and here's a decoded version of that command. And the third example is using a tool called batch encryption. And the obfuscated batch file is only one piece of the full component. But basically, it's initially it's creating a custom environment variable, and the name of that variable is single quote. That's it. And then they basically use known environment variable substrings to set that initial value. And then they call substrings of that value, that single quote, in the rest of their command. So it gets pretty crazy pretty fast. There's a lot more information. This was a very interesting phishing document. So if there's any, well, I won't say that. I would advise you to look at the white paper if you're interested in what this document was and where it came from and some of the potential political motivations behind this one. So, advanced payload obfuscation. How do we put all these pieces together? Well, if we start with this command here, I assemble this command, and if there's any defenders, then the first part may look pretty common. Comspec bc start bmin. So, if anyone has ever used comspec in any of their payloads, there's a good chance it's gotten detected if you're like setting it in registry or services or something like that. Metasploit and a lot of other tools will use comspec. But I use this as a command because I wanted to use something that defenders would probably laugh at and say, well, I detect that. And then see, well, how can we mess around with this that maybe we won't detect it? Because ultimately, that should be our job, is to always question our assumptions, question what's possible from a syntactical perspective so that we can all get better together. So this first part, comspec is the environment variable with a full path to command.exe. B, exit code. C, the remainder is arguments, etc. So if we have defenders who are looking for comspec in registry and services and event logs and stuff like that, what are ways that we can still get the same value of comspec but not show up as %comspec%? One way is with these 27 characters, we can use substrings that will still produce those same 27 characters. So I'm saying, give me the environment variable of comspec and give me the substring starting from the 0th index going 27. Or starting with a negative, starting from the end and going back 27 characters and then giving me the next 27, right? These four will still produce the exact same value. In addition, we can use even larger values and start from the 0th and go out 1,337 characters. It doesn't matter. It's going to give us the same value, which is the path to command.exe. Another thing we can do is using environment variable substitution, which is what FIN7 was using, but kind of for different purposes. We can say, okay, give me the comspec value, but replace backslashes with forward slashes, which will still execute perfectly fine. Or we can use values that we know won't exist. So we'll just choose two of these and keep obfuscating them a little further. We can randomize the case of the environment variable. We can actually add significant white space in certain places for these environment variables. And then we can explicitly sign the indexes. So I don't know about you, but seeing a positive or negative signed 0 is kind of a suspicious thing on the command line, but technically it's possible. So we'll go with a second option and put that back into our command. Now, a really important thing here is that context is crucial. This will work if you copy it into a command prompt, or if you're in a context that understands this is being interpreted by command.exe, like wscript.shell. This will not work if you copy and paste it into a registry, like or a scheduled task or service or something like that. Basically, in those contexts, there's literally like a find and replace on %comspec% to replace it with command.exe, but those contexts don't understand this crazy substitution syntax. So the context of command.exe is really important for this initial technique to work if the very first thing is command. So let's keep going. For the rest of the command, we can randomize the case. We can also remove a lot of white space. So we had BC start bmin with white space. We can actually smash all of those together. And the interpreter understands argument by argument how to parse it out. A fun fact here, if you'll notice, our comspec variable, again, is going to expand to command.exe, and then we have /b starting next with no white space. the interesting thing is that the operating system actually forces an extra white space when you actually look at it either in the command line logs or through live process auditing, and it actually adds this white space. So here's an example of you can have a detection that is 100% awesome at statically detecting a rule that's in registry or services or something like that, but will fail if you don't take into account the way that it's processed after it runs. So sometimes you actually need to tune your detections to have different for static and dynamic, or to basically make it in such a way that it can handle both scenarios. That's why it's important to test your data sources to know which data source am I working with. So we can reorder ANO to NOA, doesn't matter. We can also add white space. We can add all those commas and semicolons we talked about. Anywhere where there's a white space used as a delimiter, we can add any number of commas and semicolons. We can then add several different layers of carets, and we add different layers to basically escape themselves so that they still persist in the lower layers of sub-process executions. And if we actually run this command, then starting from the bottom up, there's 4 process executions. We have the find string as its own process, the final net stat as its own process, and this intermediate process here, and we're going to talk about this later, but this highlighted blue portion, this is a really fascinating artifact of the operating system that's produced in certain cases. But basically, if you ever see command.exe space /s space /d space /c, no space, double quote space, and then something, then that's indicative of this operating system performing this additional execution, which can actually be really helpful for some detections. But again, we'll talk about that later. But as you might notice, well, the netstat command is not obfuscated. It didn't carry any of those carets or commas or semicolons. So, did this really bias anything? And this is why I said that a lot of defenders would maybe look at this and say, well, I don't really care about this because dynamically it resolves. I'm still going to find the child process. Well, there are things we can do. So commas and semicolons and carets don't persist into this process. But a double quote would. So as long as we used evenly paired double quotes, they will persist into child processes. Now, the caret didn't persist because netstat doesn't have any concept of the caret. It's not an escape character to netstat. But technically, the double quote doesn't have any meaning either, but since it came from command as a parent process somewhere in that chain, it persists down, and it's kind of an artifact of how the arguments are assembled, and it will persist into that final process. So now, as a defender, if I was looking for netstat, ANO, or NOA, or etc., I'm going to have to deal with double quotes appearing almost anywhere in the argument for any child process. That starts to suck. It's a lot of extra work for us. So Invoke-DOSfuscation will basically take any arbitrary command, and if you start your command with this extra obfuscation of double quotes or something like that, it'll maintain that throughout all the layers of obfuscation. And this is actually really difficult because with PowerShell obfuscation, you can actually harness the power of the abstract syntax tree, the tokenizer, to know of this command, which part is a command, what's an argument, what's a string. Command doesn't have any of that stuff. So this slide is my world's tiniest violin, looking for some sympathy. Basically, there were several fringe cases of this project that were really hard because you're basically working with no additional visibility, but it is still possible. So again, for the defenders who may say, okay, dynamically, maybe netstat will show up with double quotes. I'll just remove double quotes first and then apply my rules and go from there. Well, I would argue there's still tremendous value in looking for the presence of obfuscation. Even if you have a way to decode it, the presence of obfuscation gives you insight in maybe there's something shady going on here. That's a signal in and of itself. Why is there an obfuscation attempt here? And to counter that, I would also say there are a lot of things that you can do from command.exe that never spawn a child process that I would still like to know about, even if it's just in this crazy encoded blob. Creating files. Maybe the attacker wants to echo something to sinkhole your cloud security product by echoing, localhost into your host file for that. That's a big deal. And if all these commands in red are totally obfuscated and looks nothing like that, and there's no child process, I would still want to know about it. So I propose there's still value in detecting obfuscation in and of itself. Plus, if you put in the legwork to do that here, then you get the benefit of being able to search statically in a lot of places for these obfuscation techniques, which is how I found the previous obfuscation techniques of those crazy obfuscated batch files. So let's say you're a red teamer and your target is looking for all these different characters, right? They're on their game. They're looking for commas, for semicolons, for carets, for double quotes, all this stuff. And if you try to use one of those techniques, you're going to get burned. At this point of the research, I really was wondering, can I get away with murder on the command line without these characters? Because if I can, then I need to have detections for it. So basically, this led me to come up with 4 different ways to encode entire payloads without having to use a single one of these characters, but still having the option to if I want to. So the first one is concatenation. So netstat ANO, another fun thing we can do is instead of tac ANO, we can actually use a slash. Now, this actually might burn a lot of detections because, kind of as a side bonus, anywhere where you see a dash or a /, there's a good chance that they're interchangeable. So if you're writing detections based on wscript / no logo, you can use a dash instead. Or if you have PowerShell detections that are looking for a dash encoded command, you can use / encoded command. Same with regserve. A lot of detections are written looking for /i HTTP, but you can use a dash instead. And fun fact for this one, if you look at the URL, you can actually change // to backward slashes. And in some languages like PowerShell, you can actually use a forward and a back, or a backward and a forward, etc. And it gets really crazy really fast. So it's important to kind of poke at these commands and see, hey, when I write this detection, does it always have to be a dash, or can it also be a /? And if that's the case, I want to look for both. And maybe I want to look for the / exclusively because it's really weird and no one should ever do that. So if anyone does, then I want to know about it. So what we're going to do is we're going to take our command and we're going to set it into a process level environment variable. In this case, we'll just call it com for command. And let's just echo that com just to make sure it actually set the value right. Now, if we echo it in the first example here, we actually don't see the value. We just see %com%. And the reason is that command.exe is not going to automatically expand that value in the current session. 2 ways we could do that, not the only ways, but in the bottom example, if we just spawn a child process and then echo %com%, it works because a child process, as any subsequent child process, will automatically expand the value. But if we want to stay in the same session, we can use this call internal command, which says expand the value of this variable. So in that case, when we echo %com%, we actually get the netstat command. So let's use that. So we're going to call %com%, and as we can see, it runs our netstat command. Awesome. Baby steps, we can set our command in a variable and execute it. Well, what we can then do is chop up our command into a couple of variables, let's say 3, and then call the reassembly of com1, com2, and com3, and it also executes it just fine. Now in this case, this is screenshots from sysmon of the process execution. And if you'll notice here, for %com1%, anywhere where there's 1% in your command, there's actually 2% in this. And this is actually from a bug in a parsing bug in sysmon. I released a blog post on it a couple weeks ago where basically it's not properly escaping the %. And it can actually bite you in a couple of weird ways. So basically, if you're using sysmon as a defender, then definitely check how you're using those because any rules written to look for single %, will get potentially broken on this kind of stuff. So we can also reorder the substrings that we set as long as we reorder them back in the call. And then we can also set the reassembly into an additional variable called final and then call that final variable. So when we actually want to launch this final command, there are 5 options in Invoke-DOSfuscation to handle this. One is the default, which if possible, and the only times this isn't possible is if you have certain like pipes or different characters that need special escaping. It gets really tricky with call. But basically, if we can do it, then let's just use call so we don't have to spawn a child process. Otherwise, we can spawn a child process and either say command C final variable, or we can echo the final variable into a child process. Options 4 and 5 are just the same, except they're using PowerShell instead of command. So basically, in Invoke-DOSfuscation, if your input command, you actually want it to be run by PowerShell in the end, then you can specify that and say, hey, the final binary to run this is going to be PowerShell, and then I'll handle in the tool all the command level DOSfuscation escaping on top of PowerShell level escaping. So all the building blocks we talked about before, let's say if the person you're going up against is not looking for all the carets and crazy stuff, we can add all that back into this command, and the tool will handle that automatically. So we can go back and randomize the case, remove white space, add white space, commas and semicolons, crazy carets, parentheses, and this is our command now. And when we run it, we'll see it translates back to a single child process of netstat ANO. And again, we could add double quotes in there if we wanted to break up those arguments. Now, one case that was really, really frustrating for me is this is fine if we have these double quotes that are adjacent, but what if we want non-adjacent double quotes? There's a huge difference here when you're using concatenation, because if we try to just change the paired double quotes to non-adjacent double quotes, this will actually fail. And it fails because there's no way on the command prompt to actually escape double quotes. The only reason this works is for the adjacent double quotes. It's almost like you took your whole argument and broke it into two pieces and just have them adjacent side by side. So when you start to move those double quotes not side by side, it gets really weird and it actually doesn't work. So it led me to come up to this 4-step solution to basically be able to have the final process run with non-adjacent double quotes. And here's what I did. Anywhere where I want a non-adjacent double quote, I first set it to adjacent, paired double quotes. The next thing I do is I set an environment variable that contains quote, quote. In this case, I'll just call it quotes. Then in our very final variable at the end, I basically use that string substitution and say, I want you to replace every instance of quote, quote with a single quote. The only problem is I can't just put a single double quote right there because that will break the whole thing anyways. We have to have evenly paired quotes. So what I do is I say, give me a single character, a single substring character of this quotes variable, which in memory is going to be one double quote. The only problem here is that the % quotes % is inside of the % final %. And so those percents are battling with each other. So that doesn't work. So it led me to try to find a way to expand a variable without using %. Turns out, if you're running Vista or later, you can use /Vista flag. Now, if you do this, it will allow you to, instead of using % for that variable, you can actually use exclamation points for that variable. So now we have exclamation point variable 1 inside of % variable 2. So the percents aren't battling each other, and this will actually run the command just fine. So our final command has non-adjacent double quotes. Now, I have to admit, this is actually a bit of a troll. There is no Vista flag. If you actually look at commands help menu, there's a /v::on flag, which is enabling delayed variable expansion. But what I found is that in addition to v::on, you could use any substring of that. And then /v almost anything under the sun, as long as it's not v::off. So in the tool, you basically will select if you ever do anything that requires this v option, it'll basically just do some random crazy string, and that's all configurable in the tool. But again, a lot of these flags are a lot more flexible than I originally gave them credit for. In addition, the environment variable names don't have to make any sense, right? com1, com2, com3 makes for a little bit easier example, but we could also just use 100% special characters as the environment variable names, or differing amounts of white space followed by any one character. So it can actually get pretty ugly pretty fast. So, dude, how can you call yourself a defender and do this kind of horrible stuff? Like, this sucks. Like, what are you trying to do? Well, I started with concatenation because we've actually seen it used in the wild, but in really small pieces. Typically, attackers will use this just to concatenate the string PowerShell before launching a PowerShell command. So this is from a link file where they basically chop up PowerShell into 3 variables and then reassemble it in a child process. Looks familiar, right? In this one, they actually have a lot of garbage garbage values being set in variables that they'd never even use. It's just to kind of, clutter up the command. And then this one is the same thing. There's also some additional carets. So concatenation has been used in the wild, but attackers have typically only used it for really limited circumstances like the string PowerShell. I've not seen it really effectively be used on the entire command like we just walked through in the previous example. So with that being said, the next 3, the last 3 payload techniques are ones that we've never seen in the wild. This is all kind of a product from this research. And when I say I haven't seen it in the wild, what that means is I've looked for it a lot in public and private file repositories, sandbox execution reports, and running as endpoint detections for over 10 million endpoints all around the world. I've not seen, prior to this research being released, I've not seen a single instance of anything like what we're about to talk about. So let's trudge on forward. The for loop. The for loop is freaking awesome. It gives us some incredible capabilities. We already saw a little snippet of this in how we were able to produce binary names with a for loop. But what we can do is, again, if you look at the help menu, when we talked about that variable expansion, it says the var syntax expands, etc., which is quite a different thing when inside of a for loop. That is a huge understatement because it is an extremely different thing inside of a for loop. It's amazing what you can do. So let's take our same netstat command, and we're going to make sure that we add that /v because we want variable expansion in this example. Another fun fact, so /C. A lot of defenders will say, okay, I know attackers can rename command.exe to something else. So I'm just going to anchor my command on if the argument contains /C, then it's probably command, and I'll look for the rest of the things there. Well, if you scroll down in the help menu, you'll find this thing that also, for compatibility reasons, /R is the same as /C. So any detection that relies on /C, an attacker could totally just use /R. And I've never seen this used in the wild, but like, that's freaking cool, right? Like, just /R, okay. So I'm just gonna replace /C with /R now, and that works perfectly fine. And so as a defender, when I'm writing detections, I wanna look for /V, /C, /R. So CRV is the way that I remember those two anchors. C and R are interchangeable, and V for variable expansion. Another fun fact, the white space between each of these arguments before the /C or /V, or /C or /R is what I'm calling a troll opportunity, which means you can put anything you want there, like literally almost anything you want, and it's not executed. It's just like characters sitting there out in just the ethers. So this command perfectly runs netstat. Another thing you could do as an attacker is maybe you'll do this. What do you think runs when you run this command? What would you expect as output? The path variable? Well, actually, no, because \C doesn't mean anything. It's /C, right? Which there happens to be one right here, and it's a /R instead of a /C. So there's tons of white space here, and as long as we're staying underneath the 8,191 character limit of command.exe, we can do something like this. So this is the actual command that gets run. So we paste that into command, and the only thing that comes out is netstat. So if you're a defender and you're scrolling through looking at logs and you see command \C echo, you may keep going but not recognize that scroll bar, the horizontal, was like that big because there's this command way out there. So text wrapping for the win. So anyways, let's go back. So we have our netstat command. For coding, what we're going to do is we're going to basically, the only thing we need is the unique characters to reassemble the final command. So for netstat ANO, nets space /AO are the only unique characters that we need. They can come in any order, but we're going to set that into this variable called unique. What we're then going to do is we're going to set a for loop that contains the index values to reassemble this command. So netstat is going to start with 0 for the N, 1 for the E, etc. So netstat ANO are those index values. And then we're going to end with one more value that's just kind of our bookend, right? Of just saying, hey, when you hit this value, then we're done reassembling. So then for each of these, we're going to have this final variable, and we're going to set, in each iteration, the substring of the unique value. So basically, we're going to append onto this final variable, character by character, each iteration, each piece, each letter of the original payload. And for each iteration, we're going to check and say, hey, are you this bookend value? If you are, then finish your loop and come out and then actually just call the final variable and execute it. This equals is actually a literal string comparison, so it's looking for the actual string 1337, but you can also use equal, greater than, etc. for the compare op operators. And this is all randomly selected in the tool when you run it. So when we run this, we'll actually see in standard output, you'll see each iteration. None of it actually hits the command line, and at the end, it will actually run the final payload. Netstat ANO does not show up in command.exe's arguments anywhere. It obviously will run as a child process. But yeah, it's pretty crazy the things you can do there. And what we can do to make it even more obfuscated is add a lot of extra garbage characters in there, and then update our index values, and it will still reassemble it, no issue. And as with the previous example, we can wrap all of the underlying character insertion techniques in. So we can add randomized casing, removing white space, adding white space, commas and semicolons, carets, parentheses, and explicit signing, positive or negative, for all the index values. One more troll opportunity that I built in is basically when you set your unique value, you can basically say, I want it to start with this custom message, and then any more characters that are needed in my command, it will just append those to the end. So there's no reason attackers can't have fun. Like, they're already making us work a lot to decode their stuff and find it in the first place, but they could still put, you know, heartwarming messages in their payloads if they wanted to, so I was trying to facilitate that. So we talked about concatenation, we talked about for loop encoding or for coding. The third one is reversal, which is really similar. It's using the for loop, but we're introducing this /L. So instead of having to spell out all the indexes, we can just say start from this value, work backwards, you know, decrement by -1 until you get to 0, and then you're done. So we basically put our command in reverse, and then it will reassemble it. And we can also add in garbage characters in there and update our values. So reversal, if you'll notice at the end of the for coding, anytime we have a for loop at the end, we don't actually just call final. We call final with some weird substring. Why is that? Well, the first time in that for loop that the final value is set, the final value doesn't have anything. So it literally sets the string bang, final, bang. So that's 7 characters long. So we basically need a way to remove that bang, final, bang from the final value. So what we can do is we can do a negative index and just go back the length of the final command and then start that way forward. We can also do a positive and say start from 0 and go forward 7 to jump over that bang, final, bang. Or we can use this substitution syntax. And if you notice, when the substitution syntax starts with an asterisk, that means if you find this string in the argument going left to right, then replace that string and everything leading up to it with whatever is on the right side of the equal. In this case, there's nothing. So it says find, final, bang, and anything leading up to it, and then completely remove it out of the command and start with what's left. And all these options are randomly selected in every payload that the tool generates. The very last one is FIN coding. And so basically what we're going to do is select characters. And this is similar to the out FIN coded command POC that I released a year ago, or last year. But basically you can take characters. So like, let's say we want to take every character T in that stat and replace it with a capital Z. So we replace that. And then we have to add an additional command to say substitute in memory capital Z's with lowercase t's. And then set that in sub1, and then we'll just execute this variable called sub1. We'll do it again and say, all right, replace all lowercase a's with 7s, do another substitutions, replace ends with question marks, etc. And so you can go through as many layers as you want, and just as long as you're pulling out character by character, piecing it back together in memory. When I wrote the POC, I didn't know about the variable expansion. So for each one of these substitutions, I just spawned a new child process. So literally the process tree was like command, 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 command. It was so noisy. It was so ugly. Because I had to do additional child processes, I had to do layers of escaping. So this was one layer of escaping for the ampersands to chain all the commands. This is 2 layers. This is 3 layers. So as you can see, there were like a crazy amount of carets in those commands. So really ugly. FIN coding, as we did in the top here, does it all within a single process and all in memory. So it's a lot cleaner. So with that, let's do a quick demo. So please don't use this tool for evil. And if you're FIN7, FIN8, or APT32 and don't call this work evil, just don't use it at all. And this tool is live on my GitHub. I released it just 2 weeks ago at Black Hat. So you're welcome to download and use it. But basically, if you've used Invoke-Obfuscation or any of those tools, the interface will seem really similar. So I try to kind of have the same look and feel. But this is the animated ASCII art, just adding in this kind of obfuscation to produce that payload. But it's going to have the same tutorial and help menu that the other obfuscation tools have. And so if we go to the tutorial, it'll show you how to set your command or the command path and how to set the final binary. For example, if you want it to be a PowerShell command. So we have binary, encoding, and payload. So binary is the first one. And this is basically just going to produce an obfuscated command line syntax to produce the binary name, PowerShell, or command. So in this case, if we choose the higher option, number 3, it's basically going to do the crazy for loop encoding, copy to the clipboard, paste it into command. As you can see, it produces the string PowerShell and drops you into a PowerShell prompt. Cool. So the binary stuff is just kind of like a little side option. Encoding, you basically, when you set a command, so let's just set a command. Let's do ping 8888 as our input command, and then let's do environment variable encoding. At any point, you can do show or show options and see what your command set and what obfuscation options you've added. So if we do option 1, it'll basically intersperse environment variable substrings. Option 3 will make the whole thing substrings with like crazy white space and stuff. And as you can see, it resolves to our ping 8888. So that's the second one. But the real meat of the project here is in the payload section, which has the 4 we just talked about: concatenation, FIN coding, for coding, etc. So let's actually set a PowerShell command and set the final binary to be PowerShell. We'll paste that in, and again we can go to show and see there's our PowerShell command, and we've set the binary to be PowerShell. Good to go. Let's look at concatenation. Everything has 3 obfuscation profiles, kind of low, medium, high. So if we do a 1, it basically kind of keeps it as condensed as possible, and we can paste that in and see that it runs our PowerShell command. We can go 3 with a high obfuscation level, and that's the command that it decided to produce. And we can run it and see that it runs our PowerShell command. pretty sucky. So let's go to for coding as the last example here, and we'll just go straight to the option 3. And that's the for coding command that comes out. Paste it in, see that it works. And so kind of as a fun finale, an exercise was, for myself, was what if I take a payload and host it on this bit.ly link, and I run it through all the obfuscation tools I've done so far. So Invoke-Cradle-Crafter will produce this obfuscated cradle. I then take that output, put it into Invoke-Obfuscation, and do a round of token layer obfuscation, which I then put as input in Invoke-DOSfuscation, which produces this command. And now when I paste this command into the command prompt, interactively, you see all this output. This will be present in standard output, and it's running a little slow because I was beating the crap out of my VM this day when I did this demo. But basically, character by character, loop by loop, it's appending each character to the final command and reassembling it in memory. None of this hits command line, and when it finally gets done reassembling, it will then echo it into an obfuscated version of the string PowerShell TAC, which will take it as standard input, and then it will run. So that was torture getting that level to work. So detecting obfuscation. Again, the whole reason I did any of this research was we saw attackers using these baby step obfuscation techniques in the wild, and I didn't want to get burned. I didn't want to miss any of this cool activity used by these FIN and APT groups. And so I wanted to see what's possible. And I wrote this tool kind of as like a custom fuzzer to basically test my detections and help me build them. So from a high level, some of the kind of concepts you can look for, and there's a ton more information in the white paper where I break down, even have some sample regexes and stuff like that. But looking for like really long argument lengths. Your mileage may vary. The detections we have to write have to work for all of our clients all around the world. And so we have a slightly different constraints we have to operate under, as opposed to if, let's say, we're doing operational security for 1 or 2 environments. You can also look for high frequency of these obfuscation characters. One thing that I found to be really valuable is looking for these internal commands that are like kind of the building blocks to all this obfuscation stuff, like call, set, find and find string are good ones as well, and saying, do I see any of these strings that are broken up by carets, or maybe that are immediately followed by or preceded by the comma or semicolon, etc. These are really, really good ways to catch a lot of this activity. I'm looking for unusual execution flags. /v is used legitimately by some products out there in the world, but /r, again, I've still never seen it used, so that could be a good indicator. Looking for this variable substring syntax, and looking for all this stuff on the command line, looking for it in the registry and event logs, service information, as well as if you have a virus total intelligence account, just like creating some YAR rules, going to town, seeing what's out there in the wild. I mentioned before the substring artifact, so that space SDC with that interesting spacing there. This happens when you have a subcommand that's run. Like in our context, this is a subcommand that's because it's executed as a subcommand in this for loop. All right, that's going to produce this one additional execution. But you'll notice that we run set as an internal command, and whenever you pipe contents into an additional binary, which find string is actually a binary, then that will produce an additional internal subcommand with the same SDC variables. And so when you actually are writing detections for this stuff, you can also write detections against these interesting subcommand artifacts that are generated by default. And fun fact, if as an attacker you'd rename command.exe to benign.exe, let's say, and you run this command, these sub-artifacts will still run from command.exe. So it actually doesn't take the name of the binary that you're running out of. So I suffer from FOMO as a defender, but for me, it's fear of missing obfuscation. Just because I'm obsessed with it and I love finding it, and especially when finding cool attacker activity when they're trying to evade detections, it makes me really happy. So to help facilitate this, it's really hard releasing research and tools like this because a script kiddie can benefit from day one, but it's really hard for defenders to really benefit as quickly. And so in the interactive tool, there's only a subset of obfuscation that is built into the tool when you're using it interactively. When you interact with all the underlying functions, every single one of these payload obfuscations has over 20 different arguments that you can put in to vary all like the percentage of like carets and like random stuff like that. And so I wanted to make it easier for defenders to use the full value of the tool, but kind of limit offensive people unless they actually go to the underlying functions. And to really kind of drive the point home, I released with the tool the test harness that I used, And this is basically what I've done with all my obfuscation tools. I treat it as a custom fuzzer, and then I just generate thousands and thousands and thousands of examples, and then test my detection ideas to see, did I detect all these things? So I actually released a test harness with this tool, and you can just run Invoke-DOS test harness. And if you don't want to run any of the tools, then I uploaded 4,000 samples, again, with a full wide range. Every single execution randomizes all those 20 arguments, so you get like a lot crazier fluctuations in the output than you ever would using the interactive tool. But with Invoke-DOS test harness, what you can do is there's this array where you can put in any regex terms to start to look for certain concepts from a detection perspective. So I actually started with these two. These are the two of the rules that I had as kind of basic starting points in the code release. So you can put those rules in there and then generate 100 events and then say, okay, I only detected, the tool basically said you detected 33 of the 100 events, and here are the rules they matched on. So then you can start to look at the things you missed and say, okay, what about this rule evaded this detection? Or what's a new detection I need to do? So this is the exact process I went through for months building out all the detections that we use for all of our clients. So I can't stress enough how I've tried to make this as easy as possible for defenders to use the data right out of the gate. And again, if you don't want to run this tool, you can just download as text files the 4,000 different options, or you can actually download security or sysmon EVTX files if you actually want to write detections against all the subcommand executions and stuff like that. So again, as a defender, you can just download these text files if you want and start grepping like your list of rules to start to build out detections. And this is the exact process that I used. So kind of the key takeaways. Attackers are using more creative command argument obfuscation techniques. Command.exe supports it's definitely far more rigid than PowerShell, but it still supports a crazy amount of kind of combinable, interchangeable obfuscation techniques. And we as defenders, we have to match the same level of creativity that the attackers use to kind of think differently about detecting, as well as trying to kind of approach these new problem spaces before they become really big problems. So with that, I just have to give a huge shout out to some of my coworkers, Nick Carr, Matt Dunwoody, been with them on the advanced practices team, that really make this kind of research super fun because we get to apply it and actually see attackers doing some really interesting stuff. And I have to give a huge shout out to my wife, Paige, because she puts up with a ton of research that's after hours on this stuff. This was a huge endeavor over the past 9 months with a lot of hours going into this, and so just a big thanks to them for letting me kind of pursue this obsession. So with that, the code is on my GitHub. The white paper is located here. The slides for this talk will be published as soon as this talk is over. I think it'll be tweeted out on the Hack in the Box. And yeah, thank you so much for your time. So there's a blinking 2 minutes up here. Actually, I don't know if you're the QA moderator yes, coming down.
Yeah, we still have some time to spend. Anyone have any questions? So we have a Q&A session.
Thank you. Hey, Daniel. First of all, I'm really impressed by this research. Kudos to you. That was mind-blowing, to be honest. I've seen quite a few obfuscation-related talks before, but none of them to this extent, especially not from both sides, like both from the offensive and defensive sides, on top of having tools released alongside it. So I'll definitely look into the white paper. But my question was related to one of the earlier points you mentioned, which was that as far as I understood, none of this applies to things like run key services and scheduled tasks. So basically the persistence part of the kill chain. Mm-hmm. And so my question is, did I understand that correctly? How much of it can apply to it? And if not, where does that put the attacker, alongside the kill chain? Is this something that would only happen, during execution? Yeah. Or can it happen earlier in other parts of persistence?
Yeah, no, that's a great question. So the only part that doesn't work, the only part that's context specific is if the very first binary you have, which in this case, DOSfuscation, everything is command.exe, right? So if you're not using command.exe as the very first thing in the persistence item, there's a lot of slides. Come on. We were talking about using the for loop or using comspec with that crazy substring stuff, like this. So this comspec thing, if you paste this into command prompt, it'll run. wscript shell, it'll run. But if this is the exact value that an attacker pastes as a run key or services, it won't run. All the obfuscation we talked about will work perfectly fine anywhere, except the very first thing, the context has to understand this is command.exe. So that being said, the for coding, the FIN coding, all that stuff will work perfectly fine, and you will find it in registry or services or something like that. But it has to start with something meaningful for the very first command.exe. So it still is going to be command.exe or %comsec% or something like that. But yeah, so for all the detections that I wrote them as static and dynamic, and so I'm looking for this stuff: process arguments, registry, services, some other artifacts, UR rules, looking for public sources and stuff like that to look for like macros containing this kind of syntax, or snort sigs, looking for the stuff going over the wire. But yeah, the only difference again is the very first mention of command.exe has to make sense to its context, but everything else will work perfectly fine. So really good question. Thanks. Any others? Got one in the middle there.
I've got two questions. Have you talked to Microsoft about adding a flag to basically de-obfuscate it, and have you tried de-obfuscating it yourself?
Yeah, really good question. So actually, I reached out to Microsoft 6 months ago and gave them some early examples and said, hey, is there any talk of basically like the amazing level of logging that the PowerShell team has added to PowerShell is just phenomenal. Module logging, script log, transcription. So I said, is there any roadmap to get some of this into command.exe, because all these things are happening in memory, but there's no visibility into it. And I don't know that it's actually on their roadmap or anything. At that point, I couldn't hand over all of the research, but I basically gave several examples and said there's a lot of scenarios here in which it'll never spawn a child process, and defenders would really care to know. So I can't speak for them. I don't know if there's any additional work being done by them to de-obfuscate. For me, there's not any current work. So people are still asking me to build de-obfuscators for Invoke-Obfuscation, which is not a public one as of yet. I won't say whether there will be one or not, but it's a crazy, hard undertaking to reverse all this stuff systematically. And with DOSfuscation, with PowerShell, you at least are able to use the .NET tokenizer as well as the abstract syntax tree to take this gnarly obfuscated command and say, all right, show me the arrays, show me the strings, to kind of reassemble that stuff. There's nothing like that for this. So systematically de-obfuscating it, I can't think of a way to do it with still maintaining my sanity. I'm sure some people who are like, memory whiz people could potentially find some interesting ways. Practically, as defenders, if you see this kind of stuff run, then my advice, and definitely do this in a VM, because if you're a savvy attacker, you can actually make this backfire for defenders. But basically, after we do all this crazy stuff, we still have to call the thing at the end, right? We still have to call. It's always setting it in a variable and then calling it or piping it into standard input or something like that. So basically, in a VM, take the obfuscated command and just change that call to an echo. Or if it's echoing the thing into command, just remove the pipe command, and you're just echoing a standard output, the result. But again, do it in a VM, because if the attacker has creative options in here, then even just echoing it could actually pipe stuff into other things and execute it without you knowing it. So yeah, I think I'm at time. I want to be respectful of the next speaker's time, but please, I'll be around all day, so please come find me and just say hello. And really, this is my first hack in the box, first time in Amsterdam. It's been really awesome, and looking forward to meeting you all. So thank you very much.
Warm applause, guys.